Now the third chapter, which is limits. So you are all of you are well aware about this concept of limit, and you have done lot of things with limit of functions, right? So the first thing is limits of functions. So the first definition is a cluster point, and the definition is: let A is subset of set of real numbers. A point C, which is a real number, is we call it as a cluster point or limit point of A if for every delta greater than 0 there exists at least one point x in A with x not equal to C, such that absolute value of x minus C should be less than delta. And don't remember the definition, remember the concept. So what is given? Suppose A is subset of set of real numbers. That means A has real numbers as an element. So some point C from the set A or outside set A. C is just a real number. It is not mentioned that it is definitely a point inside set A. So a point A, C is a cluster point, or call it as a limit point of set A if for every delta greater than 0, delta is what? Any real number, there exists at least one point x which is not equal to C, such that distance between x and C is less than delta. Simply it means that real number C is a limit point or cluster point of subset A of R if there exists at least one point other than C, so that distance between x and C should be less than delta. It means simply if C is a real number and is a cluster point of A, set A, if every delta neighborhood C minus delta and C plus delta of C contains at least one point of A distinct from C. That means if this is a real line, if this is a subset A, then point C is a limit point if at every delta neighborhood of point C should contain some points of A, some points of subset A other than point C. For example, if we consider A equal to 0, 1, right? So which is definitely a subset of R. So let me take C equal to half. So is it a limit point? So on real line, this is 0 and this is 1. Suppose this is 0 and this is 1 and this is half. So whether this half is a limit point or cluster point of this set A? So definitely yes, because however small the neighborhood I should draw for any delta greater than 0, delta means the radius of the neighborhood that is drawn around the point C or hub. So however small the neighborhood I draw about the point 1 by 2, so there are infinitely many points of set A which falls inside this very small neighborhood, because this interval itself 0 to 1 contains infinitely many real numbers, right? So definitely, however small neighborhood you drawn about a point C, there are infinitely many points, and from this definition what we want, at least one point other than C should be there in the neighborhood, right? So is a cluster point, and note that this C is equal to half is point of set A. If I choose C is equal to 0, so C equal to 0, is it a cluster point? Yes, definitely yes. However small neighborhood I am drawing about 0, so it will fall on the right, it will fall on the right. It will have some point 0.000 something like that. So however small neighborhood we draw, so on left there will not be points from the set A, but from right side there will be points of set A, right? So however small the neighborhood is, it doesn't matter. Very small neighborhood at 0 will also contain infinitely many points of set A, that means 0, 1. So is also a cluster point. Similarly, C equal to 1, if I take C equal to 1, it is also a cluster point, and 0 is not in the set A, right? Because it is an open bracket, so 0 is not included here. So this is example 1. If I take example 2 to be this set, so right, so for this every element of A is a cluster point of A, and 0 and 1 are also cluster point but are not in A, but they are also a cluster points. For this, all are the cluster points. Every element of subset A is a cluster point of set A, right? So now if I take set A to be 1, 2, 3, 4, 5, so now what is the cluster point? So what is my subset? If this is a real line, so my elements are, this is 1, this is 2, this is 3, this is 4, this is 5. So no cluster point, because at any point, however small the neighborhood I drawn around point C, that means either 1, 2 or out of 1, 2, 3, 4, 5. But so to include some other elements, I have to take a very large neighborhood. It is not necessary. Definition what says? If for every delta greater than 0, for every delta neighborhood, every small neighborhood, the small neighborhood should contain some other points of set A other than point C or distinct from point C. So if I draw intervals or neighborhoods like this, so they not contain They not include any other point of A. So no element is a cluster point. So no cluster point for set A. Right. So the next thing is a theorem. A number, real number C, is a cluster point. Is a cluster point of a subset A. Subset A of R if and only if there exists a sequence sequence of real numbers in subset A such that limit of sequence an when n is very large is, that means there should exist a sequence that converging to point C, and it should not be a constant sequence for all n greater equal n, or for all positive integer n, right? So the proof is that number C is a cluster point of subset of R if and only if there exists some sequence that is converging to a point C. That means a point C is limit point if there is a sequence of real numbers converging to point C. And we have to show by two ways, if and only if. By this way, if we have to consider this statement and we have to prove this statement, and the converse part we have to consider the second statement and we have to prove the first statement. So let C is a cluster point of A, then for I consider this 1 by n neighborhood, n by 1 neighborhood v 1 by n, v 1 by n at point C. So I consider the neighborhood at point C of this radius 1 by n contains at least one point an, and it will not be same as C, right? So then what happens, as we consider that C is limit point or cluster point, so that means the definition of cluster points is hold here. It means what? It means minus delta less than x minus C less than delta, and it means C minus delta less than x less than C plus delta. So x belongs to C minus delta comma C plus delta, this thing, right? So there is, as it is a cluster point, so in every neighborhood there is at least one point different from C. So then definitely this point an is in A, because by the definition of cluster point, and it will not be same as C because it is distinct from C. So it is distinct from C. So distance between an and C will be less than the radius, which is we have chosen to be 1 by n, and therefore as n approaches to infinity, n is very large, so an will converge to C. Therefore limit of sequence an will be C. right? So the reverse part is also same. So reverse part is also same. So we see the definition of the limit. Now the definition of limit of a function, and the definition is, let A is subset of R and let C be a cluster point of subset A of R. Then for a function f from A to R, from A to R, a real number L is said to be a limit of f at C if given any epsilon greater than 0, there exists a delta greater than 0 such that absolute value of fx minus L is less than epsilon when x is point of A and x is cluster point of C is cluster point of A. That means distance between x minus C is less than delta and x should not be same as C. The meaning of this thing is that, so C be a cluster point of A means what? Every delta neighborhood around point C should contain at least one point of set A and the point should be distinct from C, right? So it is this thing. C is cluster point means C is limit point means this thing, and we use this to say that limit x tends to C, right? Limit x tends to C means, so this x tends to C means C is a limit point or cluster point. It means what? X is not equal to C, but distance between x and C is less than delta. That means x lies in the delta neighborhood of point C, and we have seen that x is not equal to C means this distance should be greater than 0, right? So simplify this thing, minus delta, this minus delta less than x minus C less than delta. It means C minus delta less than x less than C plus delta. It means x belongs to C minus delta, C plus delta. But the second part, this 0 should be greater than x minus C. 0 should be less than x minus C. It means x minus C should be greater than 0, and it means x should not be same as C, right? So we have to omit C from this set. So if this is our point C and we draw the delta neighborhood, this is C minus delta, this is C plus delta. So this is a delta neighborhood and this is delta. C is deleted. So this is this neighborhood. X is point of A and distance between x and, so x lies should where here in this side or in this side, right? So this is the same concept we are using. We will use now for the limit as x tends to C. So C is cluster point, function f is a real valued function. Then a real number L is said to be limit. L is limit of this function if this difference fx minus L is less than epsilon, for which x from set A, and it is in the delta neighborhood of point C. So this is the definition of limit. That means for any epsilon, any epsilon, if we can find the value of delta, then we can say that L is limit of function f. So delta, it means that limit of fx as x tends to c is equal to L if for any epsilon greater than 0 we could find a value of delta. Right? If such delta exists, then we can say that limit of fx is L. So we say fx has limit L when x tends to c. So geometrically it means so this is x-axis, this is y-axis, this is origin, and now we interpret this definition geometrically. What does the limit means geometrically? So let A is subset of R. So we have A is somewhere here, and let F is C be a cluster point. So it doesn't matter whether C is in set A or not in set A, but it is a cluster point. That means every neighborhood around point C should contain at least one point of set A, and it is distinct from point C. So suppose this is a graph of a function f. We have drawn graph in our previous lecture. Then there exists a delta greater than 0 such that this thing modulus fx minus L is less than epsilon. So we have seen this inequality. So simplify this inequality. What does it mean? What it says? Minus epsilon less than fx minus L is less than epsilon. It means what? Adding L throughout this inequality. So it is L minus epsilon less than epsilon, fx less than L plus epsilon. So it means that it says that all the values of function fx lies between L minus epsilon and L plus epsilon. So where does the values of function lies? On y-axis, right? So for any epsilon, value of limit L is value of function fx lies between L minus epsilon and L plus epsilon. So I choose this to be L minus epsilon and this to be L plus epsilon. So my L is somewhere here inside in the middle of this interval, L minus epsilon and L plus epsilon. So what are the values taken by function? So this is the corresponding domain elements, those maps to L minus epsilon and L plus epsilon. So for fx has limit L, it means we have to find for any epsilon greater than 0, we have to find the delta. We have to find a delta, that means we have to find this delta neighborhood, C minus delta and C plus delta. If C is cluster point of set A, it may belong to set A, it may not belong to set A, and so it is a delta neighborhood of point C. So epsilon is given and we have to find a delta, right? To find delta, which delta? We have to find x in A, the points from set A, so that 0 less than x minus c less than delta. We have interpreted this thing. It means what? x should not be equal to c and x belongs to c minus delta and c plus delta. So this is the interpretation of the definition of limit. What the definition says: fx converges to L when x approaches to c if for any epsilon greater than 0 we can find a value of delta satisfying this thing, right? When this difference of f and L is less than epsilon, then our x should be what? X should be in this neighborhood of c, delta neighborhood of c, but x should not be equal to c, right? So this is the interpretation of definition of limit. Now we see the theorem. Before this we see some remark. If the limit of function f at point c does not exist, we say that f diverges at c, or limit does not exist, simply speaking. So we see the theorem. So if f from a to r is a function